Here we are back again in the PLC Professor's Workshop. This is going to be our third lecture on the comparison instructions. This time we're going to cover greater than or equal to, less than or equal to, and then the limit instruction with mask. This will be the last of the lectures on the comparison instructions. Let's jump right in and take a look at this. Combining the comparison instructions. We had to take an older project, open it up, make a few changes and save it. And the counter instructions that we're using, count up and count down, both of them are executed with an external input. Input 0 increments the changing value, and input 1 decrements the changing value. In rung number 2, we have a less than and greater than. If the value, changing value accumulate, the counter data type accumulate, is less than value 1 and greater than value 2, then true 0, 0 or local 1, 0 data bit 0, it'll be on. In rung number 3, if changing value accumulate is less than or equal to and greater than or equal to value 4, if changing value accumulate is less than or equal to value 3 and at the same time greater than or equal to value 4, then true underscore 0, 1 or local 1, 0 data 1 will be on. First question in the manual, are any of the rungs true? Yes. Which and why? Rung number 3 is true because changing value is equal to value 3 and equal to value 4. Whereas in rung number 2, changing value accumulate is not less than 0 because 0 is not less than 0. And it's not greater than 0 because 0 is not greater than 0. Therefore, both of those instructions are false. Not just one of them, but both of those instructions in rung number 2 are false. Increment the accumulate value once. So you push input 0, and now they're both rungs are false. Under what condition or conditions can rung number 3 be true with the current states or the current values of value 3 and value 4? Only when the changing value accumulate is equal to 0. So we saw the only instance where rung number 3 can be true. I'll decrement back down. So only, I'll go one more down, minus 1. So now we're watching rung number 3. At minus 1, the rung is false. At 0, it's true. At plus 1, a positive 1, it's false. I can keep right on going up with my accumulate, or go back down to 0, it's true, minus 1, minus 2, minus 3, minus 4. So you see that only when changing value accumulate is 0 is rung number 3 true. Increase value 1 and value 3 to 2. So value 1, plot the values on the number lines, less on the top, greater on the bottom. I had you plot the values on the number lines with the less than instruction on the top number line and the greater than instruction on the bottom number line. And what you should have had, because remember these are not or equal to. So you should have had an open circle on the top line on number 2. Open circle on number 2, and then a line going to the left, through minus 10 to the left. And then on the second line, you should have had an open circle on 0, which is value 2. And then a line with an arrow going to the right past 10. These instructions are not inclusive, therefore the value 1 and value 2 would be open circles on the number line, meaning they're not included in the true condition for the rung. What is the only whole number, or the only integer, that is less than 2 and greater than 0? Well, obviously 1. If I go up right now, the accumulate value is 1. They're both true, right? Well, we're talking about rung number 2. Rung number 2 is true. If I go up, it's false. If I go up, it's false. If I go down, it's false. So 1 is the only value for changing value accumulate that renders rung number 2 true with the current values for value 1 and value 2. Plot the values of the number lines less than or equal on top and greater than or equal on the bottom. Remember that we've got the exact same values in our two instructions. Value 1 is 2, value 3 is 2, value 2 is 0, value 4 is 0. So we're comparing this pair to this pair, and we're using these indicators to indicate whether the rungs are true or false. So I had you plot the numbers on the number lines, less than or equal to on top, greater than or equal to on the bottom. On the top number line, less than or equal to, you will have a solid round circle over 2 with a line and an arrow going all the way to the left. And then on the second line, you'll have a solid circle over 0 with a line going to the right all the way. If you compare the difference between the two sets of number lines, the circles and the arrows and lines are in the exact same spot. The difference is the first pair, comparing less than and greater, are open circles, which means that the values of source B are not included. The second set of number lines, source B, are included. What integers are less than or equal to 2 and greater than or equal to 0 to make that second rung or rung number, to make rung number 3 true? Okay, we're at 1 now, so I'm going to go down to 0. They're both off, correct? I'm below 0. I'm at minus 1. Now I'm going to increment to 0. Rung 3 goes true. Increment to 1. Now they're both true. Increment to 2. Now rung number 3 is the only one that's true. Go to 4. They're both false. See, the rungs look very close, but the difference is the rung number 2 is not inclusive. Those instructions do not include source B in their evaluation. So it has to be less than B, and 2 is not less than B. Whereas in rung number 3, for 0, 0 is less than or equal to 2, and 0 is equal to 0. So the rung is true. If we go up 1, 1 is less than 2, 1 is greater than 0. If we go up to 2, 2 is equal to 2, and 2 is greater than 0. We go up to 3, 3 is not less than or equal to 2, and 3 is greater than 0. The problem is the less than or equal to instruction, the first instruction, is now false. Now they're both true. Remember, this is an AND function. Increment the changing value to 2. Okay, we're at 2. Is either rung true? Yes. Why? Rung number 3, less than or equal to and greater than or equal to are inclusive of source B. 2 is not less than 2, but equal. 2 is equal to 2, and 2 is greater than 0. Increment the change in value to 3. Is either rung true? No. Why? Less is false, and less than or equal to is false. So 3 might be greater than 0 in both cases, but 3 is not less than or equal to 2 in either case. Now these instructions may seem sophomoric or too simple to even contemplate, but it is very important that you understand their behavior. And it becomes second nature, because when you look at those two rungs right now, the only reason that you know they're both false is because the outputs, if you want to call them that, the OTEs, local 1.0 data 0, local 1.0 data 1, are both off. Therefore, you know that both rungs are false. If I increment or decrement by 1, the only reason that you know that one of those rungs is true and the other is false is by the highlight of true 0, 1, unless you actually read the instructions. Now they're both true, but notice that nothing changes here other than the values. The values do change. So if you read these, is 1 less than 2? Yes. Is 1 greater than or equal, well, is 1 greater than 0? Yes. Is 1 less than 2? Yes. Is 1 greater than 0? Yes. These are both true. They're ANDed. So the rung out condition is true. Turns that bit on. And of course, if these two instructions are true, then these will probably be true as well, because this is a less than and a greater than, but it's inclusive with the equal. So in this case, both of these are true. If I go one more, now rung 2 is not true, because 2 is not less than 2, but it is equal to 2, as in rung 3. For how many values can rung 2 be true? Well, rung true can only be true right now for one value. That's for 1. How many values can rung 3 be true for? How many different values for changing value can you have and rung number 3 be true? 3. You have, it's off right now. 1 it's true, 2 it's true, 3 it's true. If you want to include the value of source B in a true condition, which set of instructions would you use? Less than, greater than, or would you use less than or equal to and greater than or equal to? Well, you would use less than or equal to and greater than or equal to. If you want to exclude the value of source B in a true condition, which set of instructions would you use? You would use the other pair, less than or and greater than. Decrement to 0, increment 0, then 1, then 2, then 3, and repeat this until clear. Let's go down to -1. They're both false. Both rungs are false. 1, 2, 3, 4. Repeat this until you understand it clearly. In the previous lab, combining comparison instructions, we had you create limiting logic. Logic that would limit the true state of the rung based on an upper and a lower limit. A less than or greater than, less than or equal to, greater than or equal to, and together. So both conditions had to be true in order to have a true state out of the rung, to make the rung true. What we have here is we have kept the less than or equal to and the greater than or equal to. We have also kept value 3 and 4 with them, so it's the same rung, but we did switch the output of that rung to true 0 from true 1, and we added the limit instruction, which we want to compare to these two instructions. I'll geezer this up. Starting with the accumulate at -3, so I'm going to decrement down to -3. Starting with an accumulate of -3, increment to a +7 while observing both true 0 and true 1, and work your way through the following list, filling in on or off. Starting at accumulate of -3, both true 0 and true 1 are off. If I increment to -2, they're both off. -1, both off. 0, both off. 1, both off. 2, both on. 3, both on. 4, both on. 5, both off. 6, both off. 7, both off. I like to go a couple values in front and behind of the range to clarify just what the limits are. Next, I had you plot true 0 on the top number line and true 1 on the bottom number line for comparison of rung number 2 and rung number 3 logical statements, meaning for what values was rung number 2 true 0, 0, that would be plotted on the first number line, and then rung number 3 on the second number line. Both number lines should be identical. On the number lines, you should have a solid circle over 2 and over 4 with a line in between. A solid circle on 2 and then a solid circle on 4 with a line in between, which means it includes 2 and 4 and everything in between, inclusive. How do those two rungs compare? Did they provide the exact same results? Yes, they did. They were identical. Did rung number true include the values of source B for both true 0 and true 1? Or rather, it would be better to say, did rung number 2 include value 3 and 4 in the true condition to make the rung true to energize the output? And did the limit instruction include both values 2 and 1, the low limit and the high limit, was it inclusive of those two values for the true out? Yes, it was. With the less than or equal to and the greater than or equal to, the functions were inclusive of source B. With the limit, it was inclusive of both the high and the low limits. What if we wanted a limit instruction, a limiting function that did not include the values between the low and the high limits? And I had you think about that before you looked at the action that I took, the change I made to the logic. So then I had you flip the values for 1 and 2 down here, make this 4, and make this 2. I see that instantly went on, so it's the opposite of the previous. Okay, we're at 7 for an accumulate, and I said to decrement back to -3 and record the results in the table. So right now, true 0 is off, true 1 is on. So it's decrement, true 0 off, true 1 on. True 0 off, true 1 on. So we're at 5. When we get to 4, both of them are on. When we get to 3, now true 0 is on and true 1 is off. 2, they're both on. 1, true 0 is off and true 1 is on. At 0, true 0 is off and true 1 is on. At -1, the same, -2, the same, -3, the same. So you see a major difference in the result of this logic, rung 2 versus this logic, rung 3. When we flip the values, they're still the same values for the limits, but now we have the more positive value as the low limit, and the less positive is the high limit. So think about this. The instruction considers these two values. All of the values that are greater than the low limit. Remember, the low limit is the low end of the range. If the low limit is 4, then because it's inclusive, it's going to be true for 4. It's going to be true for 4, 5, 6, 7, 8, 9, 10, all the way up to whatever the highest value is for that double integer, like 2 billion, whatever it is. Because the low limit is the lowest value, the least positive value in the range. Value 1 is the highest positive value in the range from the lower limit. So the only way that this could work is if you start at 4, go all the way to the highest value, go one more, and now you're at the negative 2 billion, so many million, that big number, and then you just keep increasing until you get back to 2. It's still true. then you go to 3, and it's not true. So it is exclusive of the test value, but it still is inclusive of value 1 and value 2, or inclusive of the high and the low limit values. And this can come in real handy because we're using double integers and our high and low limits are only separated by one whole number, one integer. There is only one value that limit instruction can be true. But you could open it up to make the low limit -5 and the high limit 20. It's going to exclude everything in between, but true for everything except what is in that range between that negative value and that positive value. Okay, I had you plot true 0 on the top number line and true 1 on the bottom number line. True 0 is going to look exactly as it did before. We didn't change anything yet. The top number line is going to have a solid circle on 2 and on 4 with a line connecting them. The second number line, which is for true 0, is going to have the only value that true 1 was not on for, was 2. For a cumulative value of 2, going to be off for 3, on for 4, off for 3, on for 2 and below. So you would have an open circle on the 3 on the number line, and then you would have a line with an arrow going in both directions off the end of the number line. It would completely loop around from that value all the way up to the highest positive, and then it would roll over to the lowest negative value and then back up to this value again. An equivalent to this limit instruction, but very limited, would be the not equal to 3. So if you were going to try to eliminate one value, you certainly wouldn't do it with the limit instruction. We're just demonstrating the behavior. Change value 3 to 2. And value 4 to 4. So what we've done is we flip these values. Now let's flip these values to see if this behaves the same as this. By flipping the less than or equal to, the greater than or equal to values, source B. Remember, when this was 4 and 2 and this was 2 and 4, these two bits behave the same. We flip these. Now let's flip these. Let's see if they still both behave the same. Well, you can see right off the bat they do not, because they're not both true right now. So we'll start at -2, 0 off, 1 on. With these values, the limit instruction, of course, we didn't change anything, so the results for it will still be the same. It will be on except for an accumulate value of 3 for changing value. Are there any values for the counter data type, changing value, accumulate, for rung number 2 to be true? No. Because the accumulate cannot be equal to 2 and 4 simultaneously. For one value to be less than 2 or greater than 4 is impossible. And for a value to be equal to 2 and equal to 4 is impossible. This rung would never be true. So there is no value to having the greater than or equal to source B greater than source B for the less than or equal to. We flipped these values and we got a different behavior. When we flipped these values, we did not get the same change in behavior. As a matter of fact, we got a useless piece of logic here. It won't do anything.